Welcome everyone. Now we are going to discuss about analysis on Nastran. So now I have a problem in the example. So the problem is I'm going to perform a textual analysis of a simple assemblies, and I'm going to check the stress produced in the wheel and shaft assembly when they are in contact. So that I'm just naming this analysis contact analysis. So, so my problem is this. So I'm opening the component. So it is in chapter 11, contact analysis. So wheel and shaft assembly. So I'm loading this component. This one. So now this is my component and this is my assembly. So this is the wheel and this is the shaft. So when it's both are running together, there will be stress generated on here. So I'm going to see the generated stress on particular portion on the contact. So I'm starting a simulation, advanced simulation. So my component is open now. So now I see new FEA, the next Nastran. So this is my component. So this is taking. Okay. Okay. So now I'm going to mesh. I have to mesh this performance. So I'm meshing. Before that, I'm just collecting. I'm just creating a mesh collector for meshing. So the first mesh collector is shaft. I'm naming for my reference. So I'm going to use this mesh collector for the shaft. So I can use the name shaft to understood easier. And the material I'm defining is steel. And this is the material assigned and okay and okay. So now my mesh collector is assigned here. So shaft. Now another mesh collector for wheel. So you can choose this name as pulley, and the material is nylon. I'm choosing. Since the pulley is made up with the nylon material. So I have created two mesh collectors right now. So one is for pulley and another one is for shaft. So now I have I can go for mesh right now. So I'm going to 3D tetrahedral mesh and assigning the mesh size some 5. I'm assigning mesh size as 5, and this is for pulley. So I'm selecting the pulley separately and applying the mesh for pulley. So since I have selected nylon, the nylon meshes has been generated for the pulley. So now shaft. So I'm selecting the shaft now and I'm applying the mesh right now. So if you want to make some difference in the machine also, now after meshing you can see the both parts are look like same. So what you can do, you can go with even you can go with here, you can choose edit display, you can change the color for fully all over this nylon hollow. Now you can see the pulley is the mesh with pulley is red color. It not means bad. So if you want to change the display, you can change it. So okay, I'm checking with blue color. It is good now. Okay, so now the blue color is pulley and green color is shaft. So I made the physical properties and the mesh shape. So now I can go for solution. So right click here, I'm creating a new solution file, simulation file. It's Nastran simulation millimeters. Now, so this is I'm following the same. Okay, and here my solution is linear statics global constraints. And then you can find case control. In that you can find output request. So I'm changing some output request. What are the requests now? On the force, I'm enabling the output request. Now here there will be global contact parameters, and I'm creating a new global contact parameters. So the contact changes for governance is number of contact and allowable number of contacts is I'm telling us 20. So this is it I'm defining. Okay. Now again I'm going for output request, and there you will find contact result. I'm enabling the contact result, and I'm proceeding with the settings. So my simulation part is open now. I can go to home. I'm going to apply some constraints on somewhere. Fixed translation constraint I'm going to define. So where it is not exactly on this phase I'm defining. I say okay. And then I'm going to define user defined constraint going to be happens on this phase, and here what I'm going to do, I'm going to fix the degree of freedom 2 and the degree of orientation of freedom, sorry, degree of freedom 3. Now the displacement is cylindrical, and so for my clearance what I'm choosing, I'm switching off the meshes. I'm selecting this edge. Hmm, okay. So now I have defined my constraints right now here. Now after that I need to define contacts. Now I'm going to select this icon like a simulation object type. From here I'm going to define surface to surface contact. So the type is manual because I'm going to define manually. So now for my convenient, I'm switching off the constraints, and the region 1 I'm selecting. The region 1 is nothing. This is the one. And the offset I'm giving 0.05. Proceed with OK. Now I'm switching up it. I'm switching on this one. Now the region 2 I'm defining this surface. So now I'm following this one. Now the contact has been made. So this is how you can do contacts. My two source and target regions are being set. Now the maximum such distance I'm defining 3 instead of 1. And then I click OK. So now my solution, as per my solution, I define these things. So I can solve the problem right now. Now I say solve. I'm solving the problem. The solution has been solved. So unfortunately, since I have some problem with my software, I'm able to see my result. What I'm doing, I'm loading my some other previously solved result files, the same file. So now we can find the magnitude, these results, what will happen here in that So this is my displacement, my and stress analysis, and force and reactions, everything I can see clearly. So actually the animation speed is too high. So I say animate. Actually this is what we call, the scale is too big. Let me change the scale. So I'm closing this one. I say edit. So there in the result, see the scale is 1 only. Okay. See the deformation scale is 10. I'm changing into 1. So you can see that exact result. The default scale, you can choose, click edit, and in the deformation result, it will be 10 always. So if you change to 1, you can see the real time deformation. Otherwise, you can see the 10 times bigger deformation. It will be scaled. So now this is my animation. So this is how the contacts and the stress has been generated. So this is about contact analysis, and you can see these things. You can take the results, and you can use whatever it is. Even you can create graphs. Okay. So thank you. This is about contact analysis.